Good morning to everyone. This is Kundana, working as assistant professor in BVRIT Natsapur. And today's class, we are going to discuss about water technology continuation topic. In the last class, we discussed about what is a soft water, what is a hard water, how many types of hardness are there, how to measure hardness, how to determine hardness. So these are the topics that we have discussed in the previous class. Today's class, we are going to discuss about what are the steps involved in municipal water treatment. So is that water is suitable for domestic purpose or not? What are its characteristics? That topic we are going to discuss now. So welcome to the class. So today's class we are going to discuss about portable water treatment. Before going to discuss about your treatment, let me explain you what do you mean by portable water. So the water that is used for domestic purpose, that means for household activities, for gardening purpose, for bathing purpose, for cleaning our utensils, all those things we are using the water now. That water is known as your portable water. The water that is useful for domestic purpose. Water that is used for domestic purpose is known as your portable water. Can we call all water as a potable water means? No. As we don't use the ocean water for our domestic purpose. Why? It is having more amount of salt content which will affect not only the external parts of our body, it will affect the utensils because of the scale formation. So we can't use all types of water. It should possess the characteristic. It should have certain features. Then only we can call that water as a potable water. Now, the next topic is characteristics. What are the characteristics it should possess? A potable water, first it should possess a characteristics of having colorless nature. So, water should not possess any color nature. It should be colorless. And it should not give any smell to our so that it is very tough for us to take bath also. No? So it should be odorless also. It should be odorless. And it should be free from heavy metals. It should be free from heavy metals. And it should not contain any pathogenic organisms. So sometimes while brushing our teeth, we are going to use water for cleaning our teeth. No? So sometimes we are going to take a little amount of water also. So if this possesses any pathogenic organisms, directly it will affect our metabolism. Because of that reason, it should not possess any pathogenic organisms. It should not possess any pathogenic organisms. And it should have a hardness of nearly with a range of 100 to 200 ppm. The range should be 100 to 200 ppm. Then only it is can call that water as a potable water. And turbidity. Turbidity should be less than 50 ppm. Turbidity should be less than 50 ppm. And it should be alkaline in nature. Alkaline in nature. So, after possessing all those characteristics, then only we can call that water as a potable water. That water as a potable water. Okay. So, potable water means nothing but the water that is used for consumption purpose, that is used for domestic purpose. That means for household activities. That water is known as your potable water. So, we can't call all water as a potable water. Okay, so it should possess certain characteristics. What are those characteristics means? As we discussed it here, it should be odorless, it should be colorless, it should not contain any heavy metals, it should be free from pathogenic organisms. The hardness of water should be 100 to 200 ppm. Turbidity should be less than 10 ppm. It should not have any acidic nature. Then only we can call the particular water as a potable water. Okay, so this water is supplied by the municipal people. Okay, so what are the steps involved in the treatment of potable water that we are going to discuss now? as it is very important, and it is very mandatory question for your final exams, or if you go with any mid exams also, it's very important. And definition of characteristics, definitions of potable water, and characteristics also important for your 2 marks question. So you should have a keen concept on this flow chart also. Okay, so the next one is your treatment. How to treatment of potable water. That means we know there are many sources of water. We have rainwater, underground water, reservoir water, river water. So like that, we have so many sources of water. But these sources, before reaching to home, they are following certain steps for its purification purpose. What are those purifications is our topic, that is your treatment of potable water. The first step is your source. That means from where you are going to get the water, that is your source. After getting the water from the source, that is sent for sieving purpose. After sieving, the water is sent for aeration. After aeration, water is sent for sedimentation. After sedimentation, water is sent for filtration. After filtration, water is going for sterilization. After sterilization, water is supplied to the houses. So these are the steps involved in potable water treatment. First one, source. Second one is your sieving. Next one, aeration, sedimentation, filtration, sterilization. Now we are going to discuss each and every step very keenly. First one is your source. So source means water, from where you are going to get the water. From where water is obtained. That is your source. So either it may be a river, or it may be a reservoir, or it may be underground water, anything else. So from where you are going to get the water is your source. After getting the water, we know water consists of so many suspended impurities. That means which are floating on water. So that can be removed by sieving process. That means just by passing the water through a layer which are having the pores with a very minute size. When water is passed through that one, all suspended impurities are removed. So in the sieving process, what we are going to do? So removal of suspended impurities. By using sieve. That means nothing but your gel leader. Okay, sieve. By using your sieve, we are going to remove your all your suspended impurities. So first step completed. Next one, aeration process. So what do you mean by this aeration? We know that water is coming from various sources, no? Because of that reason, there is a chance of absorption of various gases by the water. Okay, so because of that reason, it is giving some kind of bad smell, and there is a chance of having metals in the form of metals also in your water. Heavy metals will be there, or normal metals will also be there. So to overcome that problem, what we are going to do? Water is exposed to the atmosphere. When water is exposed to the atmosphere, what will happen? The metals which are present in the water will absorb the oxygen and gets converted into metal oxides or metal sulfates, with which the metals that are present in water can be removed. So in aeration, what is the first step? Water is exposed to atmosphere. Water is exposed to atmosphere. Water is exposed to atmosphere. After exposure to atmosphere, what will happen? Metal gets converted into metal oxide, or it may be metal sulfates, or it may be any compound else. That means the unstable form of metal gets converted into stable form by reacting with the atmospheric gases, with which we can remove the dissolved metals present in your water. So that is your second step. Next one, sedimentation. What is the use of sedimentation? We know that if particles are very minute, that particles are not removed by sieving process. Suppose if the size of the particles gets increased, then what will happen? It will get converted into your colloidal form. So these colloids can be removed by sedimentation process. So how it is happening means, so in sedimentation process, to the water we are adding a coagulant. A coagulant is added to the water. So when coagulant like Al2O3 is added, what is happening here? The fine particles gets converted into colloids. Fine particles gets converted into colloids. That colloids are known as your floc. This floc can be easily removed by the sedimentation process. It can be removed by sedimentation process. So what do you mean by this? Means here there will be a chamber here. This is your sedimentation chamber. Inside the chamber we have some rotors. Inside the chamber we have the rotors like this. So at the bottom we are sending water plus flocculant. Water plus flocculant is sent. So inside this what will happen, because of the continuous churning, all particles gets complete mixation. Water gets complete mixed with the flocculant. So when it is completely mixed with the flocculant, what will happen? The fine particles gets converted into colloidal particles, which is known as your floc. So because of the gravitational force, the heavier particles get settled down and the remaining water will flow. So the heavier particles gets settled down, which is known as sediment, and the remaining water will flow. Okay. So in this way, the fine particles can be removed in the form of sediments in the sedimentation process. Okay. So in the first step, that means after from the source, in the sieving process, we are removing the particles which are visible to our naked eye. That are your suspended particles. Next step, aeration. The metals which are in the dissolved form, that are removed in the aeration by converting the metal to metal oxides or metal sulfates. Next, in the sedimentation, the fine particles which we can see but we are unable to filter, that particles gets converted into coagulant form by using the flocculant, by increasing the size. So through the gravitational force, the heavier particles get settled down and the remaining water will flow, with which through sedimentation process we are removing the fine dissolved particles here. And the next one is your filtration. What do you mean by filtration? Means, I think we know already about this filtration while you people studied in your school level. Okay, tripart method, which very much familiar process where we observe in our school level. Tripart method. So in the tripart method, what we are going to do? We have three parts. So in one part we have your sand, in one part we have your gravel layers. Gravel, that means big stones will be there. In the third part it will be your pebbles will be there, and the last we will have your coal will be there. So like that, when water is passed through different layers of sand, then finally you are going to get the purified water, right? The same process and the same mechanism is followed in your potable water treatment also. What is that filtration? Let us see in detail. Filtration process. In this filtration process, water is passed through different layers of sand. Water is passed through different layers of sand. Different layers of sand, different layers of sand. So here we have two types of filtration. One is slow sand filter. The other one is rapid sand filter. Slow sand filter, rapid sand filter. Coming to these both methods, in both methods, the layers are same. There is no change in the layers. What makes it differ means in slow sand filters, there is no temperature and pressure. But coming to rapid sand filters, here we are applying some temperature and pressure. That is the differ. And coming to the layers, what does it consist of means? It consists of your first layer, fine sand layer will be there. Fine sand layer will be there. In the first step, fine sand, very small particles. In the second step, coarse sand, little bit big. Coarse sand will be there. So it is your coarse sand. And the last one is your gravel layer. Gravel layer, that means very big stones will be there. Gravel layer. And finally, you are going to get your water. So here, water is sent from this inlet, and the after purification water is coming through this outlet. Okay, in both the cases, the layers will be same. But what makes it differ means in slow sand filters, there is no application of temperature and pressure. And it is a open environment. And coming to rapid sand filters, the rapid sand filters, here the process takes place in the presence of temperature and pressure, but it is a closed system. It is a closed system, and whereas it is a open system. So in this step, what we are going to do? We are going to remove the particles which are at sand size. Even at sand size, particles are also removed. Okay, this is about your filtration. Next step is sterilization. Next step is sterilization. That means in the above steps, we removed all your suspended impurities which are visible to our naked eye, which are not visible, which are minute in size. That means all your impurities are removed, but we didn't remove any pathogenic organisms that are present in the water. So to remove that pathogenic organisms, we should go for your sterilization process. So what do you mean by sterilization means? The step in which all pathogenic organisms are destroyed is known as sterilization process. In this step, what is happening here? All pathogenic organisms are destroyed. All pathogenic organisms are destroyed in this step. Okay, but this sterilization can be done by various methods. First one, boiling method. I think this method is very much familiar for every house. Okay, but this method is not suitable for municipal water treatment, as municipal water is very high in amount. So, okay, a big tank of water will be there. It's very tough to boil the water, and it is not suitable for your municipal water treatment. So, in this step, what we are going to do? Water is boiled to 100 degrees centigrade. At 100 degrees centigrade, maximum organisms, microorganisms gets destroyed. It gets destroyed. But what is the problem here? This method is only suitable for a family. That's it. But it is not suitable for municipal water treatment, as it is very high amount of water. But it is not suitable for municipal water. It is not suitable for municipal water. Okay, as it is very large amount of water will be there. Due to large amount of water, very tough to boil. Large amount of water is tough to boil. This is about your boiling. Next one is your ozonization. Ozonization. What do you mean by this ozonization? Means passing ozone gas to the water is known as ozonization. Here, what is happening here? When ozone gas is passed, then what is happening here? This ozone undergoes dissociation to liberate oxygen and nascent oxygen. This nascent oxygen is acting as a disinfectant. This nascent oxygen is acting as a disinfectant, which destroys the microorganisms and which will give the pure form of water. But the only problem with this ozonization is the ozone gas is very expensive. So that means it is not affordable by the government for the treatment of municipal water. Okay, the only drawback is this: the best method. It is the best method. It is the best method. But the only problem with this one is it is expensive. It is expensive. So what is the disinfectant acting to kill the pathogenic organisms when ozone is passed here means it is your nascent oxygen. So this is about your second sterilization technique. Coming to the third one. Third one is your chlorination, which is very much familiar. Chlorination process. Chlorination. So what do you mean by this chlorination? Treating the water with chlorine gas is known as chlorination. Treating the water with chloro compounds. Treating the water with chloro compounds is known as chlorination. So what are the compounds that are used for your chlorination that we will discuss, and why we are using only chlorine means chlorine will kill the microorganisms very easily and it is available in the nature. It is abundantly available in the nature. Because of that reason, this is the best method for municipal water treatment. So under this method, what are the various different methods we have, we will discuss first. First one is treating the water with chlorine gas. Second one is treating the water with chloramines. And treating the water with bleaching powder. So when water is treated with chlorine gas, then what will happen? It will undergoes reaction with your water and it liberates some compounds which is acting as disinfectant. But fortunately, in all these compounds, if you take chlorine gas, Cl2 is reacting. If you take chloramines, here also we are going to have your CH2Cl plus NH3. So here chloramines and here CaOCl2. So we are using three different compounds here, but fortunately all compounds are giving same type of disinfectant finally, that is chlorine reacts with water to form HCl plus HOCl. Okay, so this is the final reaction in three different types of chloro compounds. If you take bleaching powder, if you take chloramines, if you take your chlorine gas, the final output is chlorine reacts with water to form HCl, that is hydrochloric acid, and the next one is your hypochlorous acid. Hypochlorous acid. Okay, this hypochlorous acid is the main disinfectant to kill your pathogenic organisms. So hypochlorous acid is the main disinfectant to kill pathogenic organisms. Okay, so this is the best treatment to sterilize your municipal water. But here we have very interesting topic. So we know that whenever in our houses also, whenever our water tank is cleaned with the bleaching powder, immediately we are going to experience the change. That means either it give some bleaching smell or bleaching taste to your water. That means if chlorine is not added in the required amount, it will give bad smell and bad taste to your water. If it is added at less amount, it will not kill the microorganisms. So what is the amount that of chlorine that is required, that we are going to know that. So that amount is known as breakpoint chlorination. breakpoint chlorination. So what do you mean by this breakpoint chlorination? Means amount of chlorine, very important, amount of chlorine required to kill bacteria. Amount of chlorine required to kill bacteria is known as chlorination. So what is the minimum amount? The minimum amount of chlorine required to kill pathogenic organisms present in the water is known as breakpoint chlorination. Okay, if less amount of chlorine is added, what is happening? If more amount of chlorine is added, what is happening? That we are going to discuss by using a graph. So, when a graph is plotted in between applied chlorine and residual chlorine, applied chlorine, residual chlorine, then what will happen means you are going to get a graph like this. Okay, this is your A grams, this is your B grams, this is C grams, this is your D grams. Okay, when a gram of chlorine is added, then it just oxidizes the material. It just oxidizes the material. If B grams of chlorine is added, then what is happening? It is forming the chlorocompounds. That's it. It is forming the chlorocompounds. If C grams of chlorine is added, it is killing the microorganisms. Destruction of bacteria. It undergoes destruction of bacteria. If D grams of chlorine is added, then it is forming residual chlorine. Okay, so that means treating the water with chlorine will kill the bacteria, will kill your microorganisms. But what is the required amount that we should add is very, very important. For this much liters of water, this much grams of chlorine should be added. That is the minimum amount. What is that minimum amount is known as your breakpoint chlorination. Suppose if chlorine is added less, that means if A grams is added, it means just it is oxidizing the material. Okay, if B grams are added, it is forming the chlorocompounds. If C grams are added, it is killing the bacteria. If D grams are added, then it is remaining as it is, and it is known as your residual chlorine. That means among all this A, B, C, D, which grams of chlorine is most effective to kill the bacteria? C grams. C grams of chlorine is the minimum amount to kill the bacteria. That point is known as breakpoint chlorination. That point is known as breakpoint chlorination. If chlorine is added more than the D grams means it will give bad smell. If it is adding more than the D grams means it is giving bad smell and taste. Bad smell and taste. To overcome that problem, we need to treat the water with sodium sulfate. Sodium sulfite. So when it is treated with sodium sulfite, automatically we can remove the excess chlorine present in your water. So this is how municipal water is treated. So in the first, what is a municipal water? That means what is a potable water? What are the characteristics? What are the steps involved in it? And in the step, what is each step we discussed it here. And finally, we discussed about your sterilization process. Okay. The next topic, desalination of brackish water. So next one, desalination of brackish water. Desalination of brackish water. So what do you mean by desalination of brackish water? Before going to discuss the topic, first we will discuss what do you mean by a brackish water. Brackish water means nothing but your sea water. Sea water is known as brackish water. What do you mean by desalination? The desalination means removal of salt. Removal of salt is known as desalination. Okay, now removal of salt from sea water. So what is our topic? So how to remove the salt from your sea water, that we are going to discuss here. Actually, we have many methods. So we have RO method, we have electrodialysis method also there. Electrodialysis also there. But according to our syllabus, we have reverse osmosis method. Reverse osmosis method. So this topic we are going to discuss now. The reverse osmosis. Reverse osmosis. So before going to discuss about this reverse osmosis topic in detail, let me clarify one thing first. First, what do you mean by a solution? Solution means nothing but the combination of solute and solvent. The combination of solute and solvent is known as solution. Right? Next, diffusion. Diffusion. So what do you mean by this diffusion means? So we have higher concentration, lower concentration. So higher concentration means nothing but, so we have higher amount of your solute particles. Lower concentration means nothing but we have lower amount of your solute particles, right? So what do you mean by diffusion means? Movement of solute particles. Movement of solute particles from high concentration to low concentration through the to the low concentration is known as diffusion. Here which particles are migrating? Solute particles are migrating. So diffusion means movement of your solute particles from high concentration to low concentration. So if you lit an agarbatti in a room and keep it in one corner, you can experience the fragrance in another corner. Why the thing is happening? Let us in that case complete atmosphere as your solvent and that agarbatti as your solute. That means your solute particles are migrating from higher concentration to the lower concentration. This is known as your diffusion. Next, osmosis. What do you mean by this osmosis means? Movement of solvent particles. Movement of solvent particles from dilute solutions to concentrated solution. So low concentration means nothing but dilute. High concentrated means nothing but concentrated. So movement of solvent particles from dilute solution to concentrated solution through a semi-permeable membrane is known as osmosis. Is known as osmosis. Suppose if the process takes place reversely, that means if the solvent particles are migrating from concentrated to diluted side, then it is known as reverse osmosis. That topic we are going to discuss now. So what do you mean by reverse osmosis means? When two different concentrated solutions are taken, two different concentrated solutions are taken and that are separated by a semi-permeable membrane. When two different concentrated solutions. So this is your semi-permeable membrane. This is semi-permeable membrane. Semi-permeable membrane. And this is, here we have high concentrated solution. Concentrated solution. And here low concentrated solution. So actually what will happen? Osmosis means particles start migrating. That means your solvent start migrating from low concentration, means here it is dilute one. Dilute to concentrated. So solvent particles start migrating from dilute to concentrated through semi-permeable membrane, then it is known as osmosis. But whenever hydrostatic pressure is applied, on higher concentration side, so hydrostatic pressure is applied, hydrostatic pressure is applied on concentrated side, then this hydrostatic pressure should be equal or greater than, osmotic pressure. Then what will happen? So because of that hydrostatic pressure, particles, that means your solvents, start migrating from concentrated to dilute side. Okay, so this is your solvent now. So your solvents start migrating from concentrated to dilute side through the semi-permeable membrane. Then the type of, as the process is taking reverse to that of osmosis, then it is known as reverse osmosis. Okay. So generally osmosis means movement of your solvent particles from low concentration to high concentration through the semi-permeable membrane. But whenever hydrostatic pressure is applied on the higher concentration side, then solvents start migrating from concentrated side to diluted side. As the process is taking place reverse to osmosis process, then it is known as reverse osmosis. And here the pressure that is applied should be equal or more than the osmotic pressure. Osmotic pressure means this pressure. This is your osmotic pressure. Okay, and this type of filtration is known as hyperfiltration or superfiltration. This is the method that we are going to observe in all our water purifiers. So all water purifiers, we are observing this method. So that means your Kent, or it may be AquaGuard, or anything else. So in any water purifiers, what is the process involved here is your reverse osmosis process. Okay, let's have a brief review on the overall topic. So what is our first topic? First one is your potable water treatment. Before that, what is a potable water? So domestic purposely used water is known as potable water. Characteristics means these are the characteristics. It should be colorless, odorless, free from heavy metals, pathogenic organisms. It should have less turbidity. It should be alkaline in nature. Next, what are the steps involved in potable water treatment means? First one, source to sieving. In the sieving, suspended impurities are removed. Next one is your aeration to remove your metals which are present in the dissolved form. Next one is your sedimentation by converting the fine particles into your flock material using flocculant. Next one is your filtration. Here slow sand filter and rapid sand filters are there, where water is passed through 3 different layers of sand. Next one, sterilization. Here we have 3 different methods: boiling, ozonization, chlorination. Among all these 3 methods, chlorination is the best method, as chlorine is most abundant material and it is easy for removal of your microorganisms. Whereas ozonization is expensive, boiling is not suitable as it is very high amount of water. Next, we discussed about your chlorination. What is the minimum chlorine that is required to kill the bacteria is known as breakpoint chlorination, and it is explained by using your graph. Among all these grams, A grams, B grams, C grams, D grams, A is for oxidation, B for chlorocompound formation, and C to destruct bacteria, D it will remain as it is. If it is excess in amount, it will give bad smell and taste. For that sake, that water is treated with your sodium sulfate for dechlorination purpose. For dechlorination purpose. And last, we discussed about desalination of brackish water. So what do you mean by desalination? Means removal of salt water is known as desalination of brackish water. Here we have reverse osmosis method and electrodialysis method. And now we discussed about your reverse osmosis method only, as it is included in our syllabus. In the reverse osmosis, how the solvent particles are migrating from higher concentration to lower concentration, and if it is a hydrostatic pressure is applied, what is happening, that we discussed it here. And this reverse osmosis method is the basic method that is present in all our water purifiers right now. So in today's class, this is the topic we are discussing now. In the next class, we are going to discuss about how to remove the fluorine from water. Also, how to determine fluorine, and what are the various techniques we have, that we are going to discuss in the coming class. And thank you. This is Kundana signing off.
Like, share and subscribe. Hit the bell icon for more updates.